Okay, any questions? I'm going to start. Does the effect of FGF1 depend on leptin or leptin receptor?
For FGF1.
Yeah.
FGF1 doesn't really change leptin levels. So we've looked at that pretty carefully, and it's not a modulator of FGF1 signaling. It also doesn't change adiposity, so, and that may be why it doesn't change leptin, because leptin is kind of very sensitive to adipose, changes in adipose depot. So it's probably not directly a leptin effect, and also you can see it works in leptin receptor knockout mice and leptin deficient mice. The glucose lowering effect in the leptin deficient and leptin receptor knockout mice, the DB and OB are even greater than just in a regular high-fat diet mouse. And I should say the degree of glucose lowering is really directly related to the extent of insulin resistance. So the more insulin resistant you are, the bigger the effect. But once you normalize insulin sensitivity, you can't get any more sensitive than being insulin sensitive. And so the glucose just stops at that point. So you can't get a hypoglycemic effect with this drug no matter what dose you give. You get normal glycemia and then you're sensitive, and so as a result you can't actually overdose. That's why I said you can't overdose on it. Roberta.
I'm always struck with how men and women have such different metabolism. Were there any sex differences in the effects of the FXR or FX on the male versus female?
It works in female mice. We haven't done that as detailed as we should, just enough to confirm that it is not like a lost property there. And I wouldn't say it's identical, because every time we look at female mice in the same study, we're most looking at male mice, there's almost always a difference. And I know a lot is put into things like cycling, but I'm not really sure that is the effect. But there's almost always a difference. It doesn't ever really just average out. But it does, the general principle does work.
Yeah, I was very impressed with the Masson trichrome staining in your FGF1 knockout animals. So that was generated by putting the animals on a high-fat diet, and you get almost a kind of a saponization, I guess, of the fat depots there. If you actually put them back on a normal diet, I would imagine that there's really sort of screwed up vasculature around there. Are they able to mobilize any of that fat if you were to actually normalize their diet?
It's a great question. In fact, what we think and what I believe, we have partial evidence, is a lot of it is about vasculature. And so my own view is that if you go all the way back to Vesalius, the physiology is dependent on really two things. One is hormones or signals getting to places, and vasculature is an essential feature of that process. And so if you underestimate the role of vasculature, you're going to be missing a huge part of how systems work. And the point of the nature of the vasculature is that after you've eaten and after the adipose tissue has lowered the nutrients in the blood, that tissue is very metabolically active while there's nutrients. But when there's no nutrients, the adipose depot becomes very quiet. And quiet means no blood flow. Any part of your body that's not active, like your muscles if you're not exercising, will have low blood flow. The nature of tissues becoming active in terms of blood flow is really important. It's key for adipose remodeling. And so the adipose tissue burns a lot of energy to unlock itself, to go into a metabolically active state, to suck in the nutrients from the body, to pump these in, to store them, to convert them to cholesterol or triglyceride, and to esterify the fatty acids. And so there's a lot that's going into that energetic process, and blood flow is very high. If there's nothing, so bile acids give the signal to increase blood flow, and FGF1 does that as well. normally. So without FGF1, you don't get that signal, and so there's a very hypoxic state of the adipose depot. So I think that's part of the reason that you get into that stress response.
Okay, well, if there's no further questions, let's thank Ron again. Thanks.